Okay, today's lesson is on how we can use a derivative function to tell us things about the graph of the original function. We'll see how the behavior of the derivative and its relationship to the behavior of the original function. We're going to start with a familiar example, parabola f of x equals x squared. And the derivative of this function, f prime of x, would be 2x. So on the screen you can see the graph of the parabola, f of x equals x squared, and then also we isolated one point on the graph, and the point is 0.9.81, which is right here, and then we drew the line of the tangent at that line, and the line of the tangent is the same as the graph of the derivative of that point. Okay, so here's a bunch of points for A, and you need to find out what f prime of A would be at these various points. So for a -2, -1.3, -0.5, 0, all the way up to positive 2.1. So I need you to compute the values of f prime of A, which, here they are. Well, you know, they're just inputted right here, right in red. And then sketch the graphs of these points. And so you'll see, here's the graph when it's 2, and it goes down to where the graph is when A is 0, f prime of A would be 0. Okay, so I want you to describe any patterns you see in the slopes of the tangent lines. So what do you notice about these lines as they get closer to the x-axis? What is happening to the lines? And also, what is the relationship between each value of x and the slope of the tangent line? And you can see this right here on the little chart, the relationship. And then what can you say about the graph of f of x equals x squared when f prime of x is less than 0? So just take a moment to think about those. And then we will go over in the next slide some of the answers you might have come up with. So when the curve is increasing, the slope is positive. When the curve is decreasing, the slope is negative. And the slope is twice the value of x, which is what the derivative is. The derivative says f prime of x is 2x. And when f prime of x is less than 0, the graph has a negative slope. The y values, or function values, are decreasing. And two more questions. What about the graph of f of x when f prime of x is greater than 0? And what can you say about the graph of f of x equals x squared when f prime of x equals 0? So again, here are the answers. It has a positive slope when f prime of x is greater than 0. The y values, or function values, are increasing. And when it's 0, the slope of the graph is 0. The graph is horizontal. The graph is at its lowest point. So this was a very brief overview, and we'll do a lot more examples of what derivatives can tell us about the graph of the original functions. And we actually call this, when we use the first derivative, we call it the first derivative test. And basically, if f prime of x is greater than 0 on an interval, then the function is increasing, the graph of that function is increasing on that interval. And if the first derivative, f prime of x, is less than 0 on that interval, then the function is decreasing on that interval. And if f prime of x equals 0, which means that the function has a 0 slope, we have a critical point, and it could either be a local maximum or a minimum, which we will go into in our next lesson. Thank you.